different. But like you know that India is also like Ghana, it's a developing country, and we have a lot of students who don't have access to computers, and they want to learn, but they don't have the resources. So this is, I think, an initiative from SAP where we do it similarly in India also, where we go to the teachers and we train them in the basic computer knowledge so that they incorporate it to the students. And trust me, I have been part of this, and the students learn much faster than us. What we teach them in the first day and what they know at the end of the training is like they know kind of more than us, because they're too curious. They know, and they only teach you, oh no, this is not how you have to do, this is how you have to do. So that is what makes us go for these things. And we are, me and Sarah, we both are really excited. This is the first time we are, at least I'm part of this African Code Week. And yeah, and like how Sarah said, you can, once, if I am presenting or Sarah is presenting, you can either put the question in the chat, because one of us will be monitoring the chat, and you can also raise your hands. And you all have to feel free, and there is nothing like we are, it's just a two-way conversation, and we will be more than happy to answer your calls, your questions. They can be related to the course, and at the end you can ask us any other questions, whether you want to know something about the UK or you want to know about the spicy Indian dishes. Yeah. I hand it back over to Sarah.
I think spicy Indian dishes are more exciting than the dishes in the UK. Okay, so this is just an overview of Africa Code Week. So Muzamil's kind of touched on his experience in India with a similar program. So it's just a couple of kind of statistics on last year's Africa Code Week. So SAP have been running this program now for 4 years, I think. I think it started in 2016. And it really is about kind of changing lives and upskilling you as teachers, as well as so you can then upskill students and actually learning a brand new skill that will help kind of transform their lives going forward. So a few of these stats I just think are brilliant. So last year we had 3.85 million youth engaged, 47% of which were girls. So we recognise that there's a skill shortage in kind of IT skills amongst girls. So actually 47% is fantastic. There were 6,300 youths with special needs that were engaged, which is just brilliant. And over Africa Code Week, there were 55,000 workshops that were organised. I think everybody can appreciate 55,000 workshops alone is just a huge amount that's been achieved, and 42% of which were in rural areas. So again, we can see some of your comments in the chat, and we know that this is kind of like the Ghana region, but we're doing this across all areas of Africa, and I think it's fantastic that we can reach out to so many people, including those in the rural areas, and kind of give them skills that will help enable kind of their digital transformations in future. So that's just an overall introduction, following from what Francis also said, into Africa Code Week. So today will be divided into 2 sessions. So one would be, like I said, computational thinking, which we will start with shortly. And then we actually probably do the fun part and go into Scratch and start showing you code. So what we found in previous years is, without the context of why you're doing something, people have found it difficult to understand why they are doing what they are doing. So computational thinking just starts giving you a bit of a breakdown into the logic and the patterns, and thinking like a computer needs to think. So if we kind of just break that down, it's quite a lot of text here, so I will kind of take it slow. So computational thinking is where you communicate your thinking in a structured and logical manner. So to code, or to program as it can be called, is to give a series of instructions and you break it down step by step so that a computer can execute them. So without code, without program, computers cannot do anything on their own. We have to tell them what to do, and it has to be extremely precise and logical. So then it's also about analysing and solving a problem. And again, that's in a methodical way, so that the machine can do it for you. So when we talk about the instructions, and you will see this in examples, some of it might seem obvious, but actually, again, to a computer, we have to really go down in like a precise and clear manner, so that we as humans can transfer those steps into a computer so they can understand it fully. So for an example, you can't tell a computer to make something have a drink. So I will pick up have a drink, but it's not going to understand that command. You have to really break down arm movement and to kind of pick up the glass. So it's really down to that granular level of detail. So then this is broken down into kind of 4 segments. So I'm going to talk through the decomposition and then pattern recognition, and then you will be pleased to know you don't have to hear me anymore, and Muzamil will take it from abstraction and algorithm. Okay, so this just then breaks down what we mean by computational thinking. This should hopefully get your mind starting to think that, and then when you're training your students, getting your students to really start thinking about problem solving. Okay, so decomposition. So this is where this really looks at kind of breaking down a problem so that they're easier to manage. So when we kind of think of a complex problem, what this is doing is inviting learners to break this problem down into smaller, more manageable parts. And then those smaller parts can be more analysed and solved for individually, and then they're simpler to work with, and then they'll build up to solve that complex problem. So that probably just sounds like a lot of theory. So an example is if you go to a grocery shop, okay? So most people, again, would just go, well, I just go to the shop. You don't have to think about it, you just go to the shop. But actually for a computer, it's not gonna understand that. So actually, let's break down what that means. Okay, so what grocery shop will you go to? There might be one up the road, or there might be one a mile away. What shop is it you want to go to, and why that particular shop? It might sell something particularly that you want, or it might just be your favorite shop. So then you need to understand what items do you need to buy. So again, you could just be looking for some kale, and you know that shop sells that kale. What time are you going to go? So are you going to go when it's busy, when it's less busy? What time does it fit in with your own agenda? And then, like, how will you go to the shop? Are you going to walk? Are you going to get public transportation? If you have a car, are you going to drive? How much money will you need? So, you know, are you going to get 1 or 2 items, or do you need to get more items? You need more money. So this is just an example of.
Aura,
Oh,
just to interrupt you. There's a question in the chat that can this session be recorded? So Francis, are you recording this session so that they can watch it again?
Yes, it's being recorded.
Okay. Perfect. Thanks. Thank you. Continue, sir.
Brilliant. Can everybody? Am I speaking at a good pace? Can everyone understand me?
Yes.
Yes, please.
Okay. Good.
Yes.
Yes, we do understand.
Good. Thank you. So yeah. So what we're trying to understand now is we're now broken down this one action of going to a shop. I know it's not a complex problem, but you really need to break it down, and then you solve for each of these smaller issues that then solve your problem of going to the shop. Another example, again with this, is if you were to build a house. I mean, building a house is a complex build. It's massive. So actually, again, how do you break that down? And this is exercises that you can do after the session. but just start thinking about, okay, what other big things would I solve that you need to break down? So with building a house, do you want it 1 story or 2 stories? Where's your house going to be? Do you need to look at environmental considerations? How many rooms are your house going to have? You need to break all this down into smaller segments before you can even build your house. And this is what we'll start programming into a computer, so they can start so the computer understands how to get to your end goal. Okay, so that's decomposition. So then when we move to pattern recognition, and you'll start to see that this is all builds into kind of this logic. So with pattern recognition, what we're looking for is similarities, trends, or patterns. Okay, so this is inviting learners to analyse similar objects or experiences, but to identify commonalities in those experiences. So once you find what those objects or experiences have in common, then you'll be able to begin to develop an understanding of the trends, and then you'll therefore be able to make predictions from those trends. Okay, so I've got another couple of examples to try and help understand what that is. But so for instance, if you think about your day-to-day routine, you probably don't think about what you do every day. You don't think about your routine, your pattern, you just probably get on with your day, however that looks like. But then when we're transferring that into coding, what we really need to start kind of seeing is, okay, so what patterns can I identify that we could use again in future? But you're not going to be able to know that until you break the pattern down. So again, let's observe the activities you do every day. So, you know, do you get out of bed? How do you get out of bed? Is there a side of the bed you get out of? You might want to go to the toilet first. I know I do. Or you might reach for a drink first. Do you have breakfast? You may not have breakfast. Or actually you might wait until later on in the day to have breakfast. You may need to help somebody else get ready in the morning. So you might have a son or a daughter or a sibling or a parent that you have to help kind of get up for the day. So then what you can do is start recognizing, actually, I always get out of bed on the right-hand side. So that's a pattern in that routine that you could use in future. And another example is if you looked at a football team, so or soccer, I think you guys probably call it soccer. But when you start looking at tactics of a team, so you will have your players in different positions, and you might find that you're never scoring goals, you never win your football game, but then you can start breaking down why. And actually, you may have your shortest player that's in defence, and actually you've recognized that tactic's not working, so that pattern that you keep using is not making you win. So actually you might choose to change that and change that observation and apply a new pattern which gives you greater success. So you can start thinking of many different examples of where you can start understanding patterns within a particular object or experience, to then start looking at pattern recognition and how you can use that in code. I hope that gives a little bit of an understanding of kind of the theory of certainly the first 2 areas, and hopefully you're all starting to think of maybe different examples yourself that you could apply this to. And certainly I know time on this call, we may not be able to kind of do activities all the time, but certainly you can start thinking of these outside of the call and see where you can use another example to give these, to kind of give these breakdowns. Okay, so I'm just going to stop talking and let Muzamil kind of take the next section, which is abstraction.
Perfect. Thanks, Sarah. Am I audible?
Yes.
Yeah, perfect. So I hope you guys are following what I will be taking the remaining 2 ones. So just to brief, just to link what Sarah just described. So what we are trying to basically tell the students later is that they don't need to see the problem as a big problem. So we just want them to learn computers by breaking this big problem into 4 different steps. So Sarah has taken us to the first 2 steps, which is first you decompose the problem into smaller ones, then you identify if there's a pattern. Now I will be taking the third one, which is abstraction. Most times what happens is when we have a problem in front of us, we will be working on things which we don't need to actually bother about, right? If you see a big problem, we have now broken down into smaller problem, and now we try to identify which all are the things which we need to take care of and which are the things we shouldn't take care of. So if we divide that, then our big problem becomes a smaller one. That's what the abstraction says. It says focusing on what is important and ignoring what is unnecessary. So just to take an example, if you see in the slide, if you are being told that you have to make a cat, right? So once you make a cat, you need to know what is its tail, how does the fur look, what should be its eyes. You don't need to think whether the cat will like a fish or whether this cat has a cousin or something like which is not related. So if we break down that, the problem becomes much smaller and you can focus. So that is the third part. So just to recap, first is the decomposition, where you divide a big problem into smaller problems, because if you think of a big problem, we will never come to a solution. Second was the pattern recognition, where we try to find out what's the pattern. And third is the abstraction, where we only think on things which are important and which is not important. We just don't think about it. So now we will go to the last block of computational thinking, which is the slide changing? Yeah. And last is the algorithm design. So now we are sure we have decomposed the problem into smaller ones, and we have also found a kind of a pattern in it. And then we also have removed which is not needed. And the final step is we need to write step by step how a task should be completed, right? So this is how our computers work. They don't work all of a sudden. They have this algorithm. If you maybe you would have heard this word many times, that there's an algorithm, right? So this is the first step, where we will go one by one step and tell how this problem will be resolved. So for this algorithm, you have to have all the 3 steps, and what comes out of this algorithm will be a program. That is what you hear it in computers when we say that, okay, the computer runs a program. So what the program is nothing, it's just an algorithm where we tell a definite steps for a computer when to start, what to do, and finally when to end. Because computer is not like a human. If you don't tell it when to end, it will keep on doing it. So these things come under the algorithm design. So these are the 4 major building blocks of a computational thinking. So this is the job of our training, that we tell it to you, so that you tell it to the kids, to the students, how a computer breaks the problem and how also they can break a problem into smaller ones. And once we introduce you to the Scratch tool, you can see how we are going to apply these rules. Because I know as of now it's a theory and it's kind of boring, but once you go into the Scratch, we will also keep telling you how we are going back to these 4 building blocks. So is this clear to you guys, or do you have any questions before I show the actual example? You can ask a question or you can type it in the chat. Or if not, then we can proceed. Good. So I have taken this example. Okay, this maybe you can type in the chat. What does it look like? The image.
Am I allowed to type in the chat?
Yeah, no, Sarah is not allowed to type in the chat. Anybody can type. What does this image look like to you?
Yeah, you can unmute yourself and answer this question. Please.
Yes,
Teachers,
you can
let's make it
unmute and
interactive
answer
for all of us.
Yeah, it looks like calculator or
calculator.
Yes, perfect. So it looks like a calculator and it is actually a calculator. Now let's take this example of if, Samuel is also correct, it's the calculator. Now let's use our computational techniques to break down this calculator into different parts. First is decomposition, then pattern recognition, then abstraction, and then we will write the algorithm for it. So how do you think, if anybody can tell me that, how, if you are being asked to develop a calculator, how will you decompose it? What will you divide it into? Anybody can answer if you want.
Please, your question again.
The question is, now we have this problem of creating the calculator. Now we have to apply the first rule of computational thinking, that is to divide the big problem into small problems. So what can you divide this big problem into before developing the calculator? Any answer. I mean, there is no right or wrong answer. It's just a thinking which we have to get into. Okay, let me help out here. So if you see in this calculator, there is an addition, there's a subtraction, there's a multiplication, there's a division, right? If we try to solve everything together, we will not find the solution. So decomposition in this example will mean, okay, let's first only work on addition part, then we work on subtraction part, then we work on division, then we work on multiplication. So that way we are breaking the big problem into smaller problems, and if we then give it to the kids, they will be able to do it faster and they will be able to complete it also. So that is the first. The second one, which Sarah explained, was the pattern recognition. So here, next thing is we will try to find a pattern. See, if I can think of a pattern where it fits, it's like, if you can imagine, like if it's addition or subtraction or division or multiplications, it's always you take first number, then you take second number, and then you multiply. You take first number, you take second number, you divide. You take first number, you take second number, you add. You take first number, you take second number, and you subtract. So the pattern here is take first number, take second number, use some operation, and you will get the result. So now if we apply pattern recognition, we have identified the pattern. Third is abstraction. Abstraction is like, oh, what we don't need. We don't need to bother what should be the color of the calculator. We don't need to bother what should be the price of the calculator, because that is not our job. Our job is just to create a calculator. So that is the third job. Once we are done with these three, we will go to the final one, where we will now write the algorithm. So that's what I am going to show it now, how an algorithm will start. So for a computer, you have to first tell start, otherwise it doesn't know. So you will see in the screen, it says start. So next algorithm step, which we have to tell the computer is, we need now two variables, like I told you, number one, number two. So computer has to create two places where you can store these values. So you see, we tell the computer, okay, now you declare two variables, X and Y, because that's normally used in mathematics. So once we declare X and Y, what should be the third step? Third step is we have to ask the user to input the first number, which will be assigned to X. Okay. Then what is the next step? Next step should be, we have to enter the another number. So if you see here, we are entering the another number. So once we have entered two numbers, what should the computer do? It has to do the calculation. It has to do the operation. So if you see, the next step in the algorithm will be do the operation. So you have done multiplication, or you have done addition, or you have done subtraction. So finally, you will get the result. See? And you got the display the result, and you say to the computer, done. So you can say next step, you see.
Sorry.
Okay, here it says stop. So this is basically the practical example of what me and Sarah were discussing, that how do you break down a problem into computational thinking, and how you break down into smaller steps, and how you at the end come up with an algorithm. So this helps us and the kids to think much they can think better, and they can also come to the they can finish the task faster. And the example which we are going to use, the tool which we are going to use, we will also be showing you the same thing. Once Sarah shows you the first application, we will use this application and we will create the same example in our Scratch tool, where we write a report, a program wherein you enter two numbers and you say addition, it does addition, you subtraction. So this will be a kind of a live example for you guys. And since in Scratch you will like it because we will not be talking, you will be also parallelly trying to do it. And yeah, this is the theory part of it. So if you have any question, me and Sarah, one of us can answer if you have any. Perfect. If you don't have any questions, so we have one activity. Normally, if it was not like this COVID where we are remote, we would have been in a meeting room all together and we could have had this kind of activity together. So what you can do it, maybe not now because we have a packed agenda, is you can do it after the meeting is over, and you can do it with the kids whom you will teach this tool. Is you can think of a monster. You tell everybody, okay, what do you think of a monster? Yeah. So they will have to do it based on these four steps of computational thinking. So first they will try to decompose it. Okay, what needs to be done to make a monster? Okay, I need a pen, I need a paper, I need some colors, and then they will have to think what is common between monsters. Yeah, I don't need to tell you that. You guys can think what's common in this, and then we do the abstraction, and then we create a step-by-step how to create a monster. In a paper, but easy, but later when you create in the Scratch tool, you will have to follow these steps to come up with your monster. But yeah, maybe once you guys develop the monster, you can send it to me and Sarah into our mails. We can also have a look at it.
Yeah, I want to see people's creations.
Yeah. Maybe Francis can send it to us, and then we can see them. Yeah.
And actually, it would be interesting to see how different the kids' monsters are as well.
Yeah, yeah. Like I said in the beginning, kids' monsters will be more creative than us because they have a lot of creativity in them. And yes, I will be just briefing you about the Scratch tool, and then I will hand over to Sarah, and she will be actually showing you it in your system. I mean, just to tell you, maybe you can type in your chat. Do you guys have the Scratch tool installed in your computer, so that we know that you also can parallelly check with us? You can maybe type in the chat yes or no. If you guys have the Scratch tool installed in your computers. Okay, so Dan says no. Yeah. Okay, fine. If it is not, but I'm sure that Francis can help you guys later to have this tool installed it in your system, because and also this session is recorded, because once you have this tool installed in your computer, you can go back to this recording and see how Sarah did it, and then you can follow it. So it's not a necessary thing that you need to do it next to us. You can just see right now, Francis maybe can answer. Francis, do we have any link which you can send it to them, or you will give them the tool later to them, or we just give right now a demo only?
We will share it with them. We will share it with them after,
okay.
After the lesson. Yeah.
Okay, you'll send it after this. Okay,
yeah.
But then you don't have to worry about it. You just need to see right now how Sarah does it, and maybe you can have a notebook next to you to see what are the steps, because I will tell you it's very interesting, because once me and Sarah started working on this, we were like kids only trying to do, oh, let me try to move this picture little left and right. It's not something boring like this, what we are talking right now. Maybe I will just brief it little bit, and then Sarah will take over. So what is Scratch? Maybe I can show it in the next slide.
Is there a delay with it? Okay.
No problem. Yeah, it's a delay. So what is the Scratch. It's a tool developed by, I don't know, you guys will be knowing that MIT is a famous university, which they have developed this tool. The problem with coding is that it gets complicated. Like you have to type. I don't know how many of you have done the coding software. It's very complicated. And it's kind of boring at times. But these guys have come up with an interface where you can easily, anybody can use it because it's just a drag and drop. If I have to move a person, I don't need to write the code. Sarah will show you how you move the person. You have to do anything. It's all in a way that even a small kid, a 4-year kid, can sit and in an hour he can create games. So it's that intuitive. And why they have provided this is so that the kids, their creativity increases, because the first time they will create a simple thing and they will get addicted to it and they will say, no, I want to move it now. Oh no, I want him to bounce now. So you are free to use it and the kids will try, and you can give this task to the kids to come up with creative games. And once they start doing it, it's not only for fun purpose. The main purpose is to develop in them intellectual thinking so that they are able to break a problem into smaller steps. And I think when we were kids, we didn't have such options available, yeah. And it's nice that today's kids have it, and there are companies who are helping us to get this thing done. And it will be really nice once Sarah shows you in the system, and maybe you can take a note of it.
And then, okay, right, I'm just going to stop sharing so I can then share my Scratch tool. Can you let me know when you can see?
Yes, Sarah, we can see the tool.
Okay, brilliant. Okay, I have. Okay, cool. Okay, cool. So in the chat, we've got the link now to the Scratch software. So whether you do it after this session, but you can download the desktop and you'll get what you can see now. Okay, so Mizamil, in the first half, while I take you through the basics, Mizamil's kind of profession is actually developing, mine is not. So I had a lot of fun kind of learning Scratch, and he's absolutely correct. You do get addicted to it. Some parts are more fun than others, but hopefully the main lesson from today is that you really start to think how you can use code to kind of make things happen. So hopefully you do have a lot of fun, as well as kind of learn the kind of core lessons from it. So this is the main kind of Scratch desktop, as it were. And I will go into each section as I'm doing activities. So I don't want to overwhelm everybody in the call, and just to kind of break it down quite simply. Like I say, I'm quite new to Scratch myself, so I could go wrong. We'll soon find out. So I don't know if anybody's heard the expression, but this little guy on the right, this cat, is known as the Scratch cat. So anytime you open Scratch, you'll always start with him. But ultimately, the wording for this is called a sprite. So in every program you build in Scratch, you always have to have a sprite, whether that's a moving sprite or a static sprite. We are going to tell this sprite what to do and kind of get him moving, get him talking, and we're going to do that by applying code. So I'll go through how you can change the sprite as well as I go through. But for the next kind of 45 minutes before the break, I'm going to go through kind of just the basics around getting my cat to have a few fun and games. So when you first go into Scratch, you can see here the File button up on the top hand left. If you click that and hit New, that will basically get you to a new screen, okay? So that's how you get to this starting place and you start a new project. So once you've kind of built your project, you're able to save it and then use it later. And then there's also an opportunity to upload your projects once you have a go. In Africa Code Week, I think we've seen a lot of really inventive projects. So I think people have really had some fun with this and created some basic games, etc. So it should be quite fun. I think I'm getting excited doing this already. Okay, so if we take the principles of what we've learned, we want to get our cat to do something. So right now, the cat can't do anything. We can click on him and move him, but he's not going to do that on his own, okay? So at the moment, he's kind of sat on the stage, as it were. So he's kind of sat in his little back, his kind of backdrop, and he's on the stage. And then what we can see down the left-hand side here, and you can see the name of these different sections and the colours, but basically these are your blocks. So they're block categories, and each category has a different set of codes in that category, which we will use to do different things. Are we able to mute? Okay, cool. So each section is named with kind of logic applied already. So you've got your motion tab. So motion would indicate anything from kind of movement. You want him to actually do something. I'll take you through looks. So again, any kind of look, you know, the look of the cat. If you've got any kind of thought process for the cat, or if it speaks, it's kind of like in the look section. We've got sounds. So when you're teaching Scratch, and certainly when you've got a classroom of kids, sound is always the one that gets everybody excited. So you can do all sorts of sounds, and it can be quite disruptive because it's just fun. So we kind of recommend that you kind of leave sound towards the end, just to make sure you can kind of keep teaching. You've got events, which I will start with, and then I'll take you through control. So we really want to control what our cat's doing. So these are the sections I'm taking you through, and then Muzammil will take you through more of the advanced kind of sections. Okay, so the first thing we want to do, as we've explained in the theory, we need a starting point. So anywhere with code and a program, the computer needs to know when to start. So if you think of a race, whether it's the Olympic Games or a football match, nothing starts until you blow the whistle or you fire the gun. So in events are basically telling you it's a starting point. When do you want your code to start? And there's a number of options. So one of the key ones is this one. So when the green flag is clicked. So if you look over here, hopefully you can see my mouse cursor, you'll see a little green flag, and that's what we are going to be using for this particular exercise. So what I can do is, if you click on the piece of code and you can drag it into the script area, you'll see here another kind of host of codes. And for example, there's one here that says when space key pressed, and any kind of code you see with a drop down arrow, it means there's more options in there. So you can see there's many different options. So on your keyboard, on your computer, you've got an up arrow, down, right, and left. So you can actually program code. So every time you click right, the right arrow, something's going to happen. Or as you can see, you can also program it to start on letters of the alphabet or numbers. So what we'd encourage is, when you're doing this, is play around with as much as you want, like put code in, remove it, and I'll show you how to do that. But it is really all about just trying things and seeing what happens to your cat. So I'm going to use when the green flag is clicked. So right now, nothing's going to happen. I haven't got any code, but I know that when I click the green flag, I want something to happen. Okay. So if we say that we want our cat to, let's get him moving first, okay? So if we're looking at moving and we just want him to kind of go for a walk, then we need to start thinking about, okay, where would that piece of code be? So we know we've got a motion block. So if we look in motion, then we've got a whole host of, again, different codes that we can start to play around with, okay? So for the purpose of this kind of exercise, I'm just going to do a simple instruction to make my cat move 10 steps. So I drag it in and drop it into my little script area. And then what you should be able to see is on this piece of code, you've got like a little nudge kind of, I don't even know what this is called, a thing that you can see can slot into something. And on this piece of code, you've got a little ridge here. So you can see that actually those two kind of fit together. So when you pick up your code and drag it, what you'll start to see is that grey area, and that shows that you're kind of ready to drop your code in. So if you let go, it clicks into place, and you can see it fits in nicely there. If I was to pick up a different piece of code that didn't have that, I can't drop that into my code. So it's very intuitive for yourselves and kids to learn, and even me, like I say, I've only learned this recently. So we want to move our cat 10 steps, okay? So when the green flag is clicked, so then if you click the green flag, I mean, you could have missed that. He did move, but very slightly, okay? So we've made him move just by saying 10 steps. So then what we can do is go, well, we want him to move a bit longer, like he didn't move very far. So what you can see is where this 10 steps is, there's like a white background. So when you've got the white background, it means that you can type something into that box. So if you double click on it, and actually you can now change this to 50 steps, okay? And then you can click the green flag and see what that does. And what you can see is he's moved a bit further. So if I drag him and pull him back, Ms. Emil touched on, you always have to have a stop command. I mean, the cat stopped because we've only asked him to move 50 steps, but you can use the red button here to stop. And then again, the green flag will get him doing that piece of code. So right now, that's quite simple. We've now got a cat that actually moves better than we did before. Okay, so then if we look at what else we can do with a cat, so let's get him talking, okay? So again, the purpose of what we're doing is to get our sprite, doesn't have to be a cat, but we want him to kind of get moving, get talking. So then if we think about where that could be, then actually I just want him to come out with a little speech bubble that says who he is. So if you look in looks, you've got all manner of different kind of code pieces, some that we'll be using today. But you can see we've got say hello for 2 seconds, say hello. He could be thinking, it could be, you know, a little kind of thought bubble. So what I'm going to do is actually pick up this one. And again, really easy, you just slot it in. So move 50 steps and then say hello for 2 seconds. So now if we applied the green flag, we've now got our cat kind of speaking. But I think that actually the cat needs to kind of say a bit more. It's a little bit boring just saying hello. So we can use the same piece of code and kind of drop it in. But now I'm going to take my hello and I'm going to say my name is, and I'm going to call him Ginger because he's Ginger. So then we're starting to build up this algorithm of what we want our cat to do next. And then when we click the green flag, he's moved 50 steps, he said hello, and he said his name is Ginger for 2 seconds. So just through this simple bit of code, we've got our cat doing a bit more than he did before. Okay. So then if we kind of look at, I keep moving my cat back, so you can see I keep dragging it back to a starting point. We can actually kind of set that up so the cat always starts in the same position. So if we kept moving him, we moved him again, he'd keep going across the screen. So what we want to do is actually say every time we hit the green flag, let him start. I always want my cat to start here, just to start from the beginning. And this starts kind of bringing a concept down here of the code and different kind of positions that you've got allocated to the sprite. So I just want to talk a little bit about this kind of section here. So we know we've got our coding area along the left-hand side. And then down here on the right, you can see the sprite. So this is sprite 1, and you can see here that it's outlined in blue. So we know that this current sprite we're using this code applies to it, and we're only talking about this particular sprite. And what you can do is you can name the sprite so it makes more sense. So I'm actually going to relabel my sprite Ginger, because again, that's his name. So then every time I look for my sprite, then I know that I'm talking about Ginger. And then what you can see along here is the X and Y axes. So X is your horizontal and then Y is your vertical. So these are the positioning of where the cat is. And I will show you something later that can help understand the concept of that. But what we're saying is where he is positioned now, he's -174 and he's 25 on the vertical. And if we moved him up here, you can then see these figures start to change. So as you move them around the screen, you can see these X and Y axes change. So this is actually really important when you're understanding the basics, but also when you start to advance yourself in Scratch, you can do quite a lot with where you position your sprite. So for now, I just want to code him. So he always starts here on the left-hand side, okay? So what I need to understand is what piece of code I can apply so that when the green flag is clicked, he always goes back to that position. So then really when we're looking, it's motion, okay? It's the motion of where he kind of starts from. So, and I mean, worst case is you start looking in all of these sections and you try and find what makes sense, but they are categorized in a way that can help you kind of know which area you're looking in. So what you can see here, there's a couple of go-to coding pieces. So you can go to a random position. So if I were to pull that in, the computer decides the random position. But I don't want that. I want to be more precise with where I want my cat to start. Okay, so if I drag this one, and you can see it says go to X and go to Y. So what I really like about this is it already gives you the coordinates of where the cat is already. So you can see -187 and 5. It's already brought that into your piece of code for you. But what you can do is you can click in and you can change these values if you want to. Okay, but I'm happy with how that code is at the moment. So then you kind of need to think where you want to start this code. So you don't want him to start moving, say hello, and then go back to the beginning. You want him to go back to the beginning from the start when you click that green flag. So there's a couple of ways you can put code in amongst code that you've already decided. So if you wanted to remove code, if you click on the bottom ones, you can take them out piece by piece, like so, or you know where you want, so I want to drop this code here. So actually, if you took the highest code that you kind of want to move, oops, I want to declick that. If you drag, it drags the whole sequence with you. So it's quite easy to just drop code in. And then I can move this and I can enter it here. And you can see there it's giving me my gray area to kind of slot into place. Or I'm going to put this back. For speed, what you can do is actually take your code, and if you start to just move it where you want it to, you'll see that the rest of the code has kind of moved down, and it's allowed you to put your code in. Okay, so if I was to put my cat over here, and then if I hit the green flag, he's gone back to my coordinates. So he's gone back to the beginning to start his very slow movement. Okay, so I think there's a, yeah, okay. So you can see already with only 4 pieces of code, we've now got our cat, we've actually now got our cat moving. So then what we can do is, I mean, it's quite boring still, right? He's not moving very far at all. So what we want is to continue this loop over and over again. And this is again pattern recognition. So when we're talking about identifying what patterns we see and how we can use them in future, this is kind of what helps us know what code we want to use continuously. So, I mean, he's moving 50 steps, but I'm going to put him in 10 steps and just so he moves a little bit slower. But then what you can see here is control. So control is really like when you're looking to control the cat, you can control many different things about him, but you want to kind of control his movement, okay? So then what you can see here, you can do repeat. So actually you could drop the code in and says, I want to repeat this motion 10 times or 20 times or 50 times. And then what that will mean is he will stop after 10 times. But what I just want him to keep moving. That's what I want my cat to do. Let's wear him out for the day. So you can see here, you've got a forever piece of code here. So what this forever piece of code does, and it's kind of a very useful one, is you can see here it's kind of looping round. So it's a forever loop. So it's going to take your piece of code and it's going to keep doing that piece of code over and over until you physically tell this to stop. Okay. So then where I want to place that is I don't want him to say hello over and over again. I think that would become annoying. But I want him to move 10 steps over and over. So actually what I want to do is, if you pick it up, and you can see here the shape fits in with these shapes here. Okay, so you can start seeing how easy Scratch is to use. But you can kind of pick and drag it up. And actually what it's done is it's looped me around saying hello. So I want to take these out because I don't want that to be in my forever loop. But then what I want him to do is say hello first. So I can click my hello and my name is Ginger. That's what he's starting with. And then I'm going to get him moving. Okay. So again, really simple. And if I hit the green flag, off he goes. Yay! He's a lot quicker. But then actually he's hit the end. He doesn't know what to do. So he's going to keep walking and he's walked off the screen. And you kind of want to get him back. So how do we do that? Okay, so we want to start again controlling the kind of sprite. So if we look at motion, okay, let's think he's hitting the edge and he's not doing anything. He's doing exactly what you've told him to do. He's moving 10 steps and he's doing it continuously. He does not know he's hit the edge and to turn around and go back. We've got to tell him, when you hit the edge, you need to turn around and I want you to walk back. So again, this is kind of where it's precise detail that you need to give this code. Okay, so then if we look in motion and see what options we've got, you can, and again, take your time and kind of go through these and really kind of see how you can start using them. But you can see here there's a piece of code that says if on edge bounce. So we know that when he hits the edge of the screen, we need him to kind of bounce back and go the other way. He's not doing that on his own. So if we take if on edge bounce, we want him to continue to do that. So when he hits the right edge, we want him to bounce back to the left. And when he hits the left, we want him to bounce back to the right, and so on. So we're putting it in that forever loop. So it's continuing to kind of do as we're asking it to do. So if I hit the green flag again. Ooh, okay. So we know he's doing something now. He's bouncing back and forth, left and right, but he's doing it in a really weird way. So I don't know any cat that walks upside down. And if you can see, if I don't do anything else, this is just happening forever and this cat's not going to stop. We need to tell it to stop, okay? So this is again, back to what Muzamil was breaking down with the calculator. You've got your starting point. You always need to end your piece of code so the computer knows when to stop. And what we really want to do is control him going upside down. This is not a good look for him. So what you can then do is kind of look at the rotation style, and we just want him to go left and right, but we want him to kind of be his upright self. So if we take that piece of code in, and actually you can see again, there's a drop down, what options have you got? Select a different option, hit start and see what happens. So for now, I want him to set the rotation style so he just goes left to right. If he'll start upside down, but he'll correct himself. And then you can see what we've done is now controlled him, so he's walking in a better manner than he was before. Okay. So then if we notice what he's doing is he's walking quite fast. so we may want to slow him down a little bit. Okay, so again, when we're kind of looking at what options we might have, we're trying to control him, we're trying to control his speed. Okay, so then thought process, you could look in it would bring me to the control kind of block of code. If you were to look in the other blocks, you may see that you're not finding what you're looking for. So it's really thinking about how Scratch has already helped you identify the kind of action you want to take. So I want to slow my Scratch cat down. I want to slow Ginger down. And then you've got here a control that's wait, and it says 1 second here. Oops, sorry. So if you click and drag him in, so we want him to wait 1 second. So this piece of code doesn't have to be, all these pieces of code don't do things in the same way. When you're kind of more advancing, then these pieces of code might work in different ways, but the concept's the same. This is controlling kind of like the speed of how he walks. So what I want him to do is actually, I want him to move 10 steps, wait for a second, move 10 steps, wait for a second, and again, it's going to go round and round. So then we can see what that looks like. Now we're trying to kind of slow our cat down a little bit because he's going to get exhausted otherwise. So if we hit the green flag, I mean, now he's never going to get to the shop, is he? Because he's walking really slow. But you can see that actually this piece of code's now actually slowed him down. He's not going too crazy now because we've made him wait after every 10 steps he's walked. So if we just stop that, or actually, no, I'm not going to stop it. I'm going to change wait. And what you can see is you can speed him up or really slow him down. But I want him to wait for half a second. So you can see he's kind of walking a bit quicker now, probably not as quick as you want, maybe for 0.25 of a second. And there you can see he's sped up a little bit, and you can play around with these figures. You can make him go a lot faster, but he's at a reasonable speed now. He's not going to get too tired out. Okay, so I'm going to stop him and kind of see what else we can do. Okay, so then what we might kind of look at is, great, we've got our cat moving. Again, the pieces of code, they're not too many, it's not too much code, and we've already got him doing quite a lot already. But for me, this area that he's in, his little stage, is a bit boring. He's on a white background, nothing's going on. It's quite boring. So this is where you can really start bringing your project to life and kind of really kind of start putting your creative flair on. And I think this is where the kids will, I mean, kids are so imaginative. It will be amazing to see kind of what they come up with. So what you can see, like we said, we're in our sprite area. And then here, what you can see is a stage. So this background is called a stage. Okay, and then in the stage, you've got, sorry, I didn't mean to click, but you can see you've got backdrops. Okay, so if you click here with the backdrop with a little plus next to it, then you can choose a backdrop. So I'm going to go into that shortly. You can paint your own backdrop, which obviously you can play around this when you've got more time. You can have a surprise. So clicking on this, it will just give you a random backdrop that you can select, or you can upload a backdrop. So you might have a photograph that you might want to upload as a backdrop to kind of make this a bit more interesting. But for now, I'm going to choose a backdrop from the backdrop library. I can just see. Can everybody hear me okay? I know some people can't, but
Yes, we can hear you.
okay.
Yes, they can hear you.
Okay, brilliant. So when I'm choosing my backdrop, I'm presented with a lot of options. So already Scratch has given users a different amount of options to choose from to bring their projects to life. So you can see I'm on all at the moment. So I've got many different backdrops I can select, like lots and lots and lots of different ones. And then these are also categorized into different areas. So you can do like an underwater scene, and maybe some of your sprites can be underwater, like fish or something relates to underwater. You can do sports or outdoors. So what I'm going to choose is, I think I'm actually going to send my cat, I'm going to send my cat to the beach. I think anybody could probably do with a beach holiday right now. So I'm going to select the beach backdrop. Then what you can see is my cat's probably in a better position than he was before, because he's got a bit more going on. He's on a beach. So then what you get the idea in the sense of you can go and choose a different backdrop and it will change it. And then if you did a backdrop as a photograph, for example, you can actually interact the cat with a real life photograph that maybe the kids in class or something. So now if we've got my cat and we hit the green flag, then yeah, he's happily just walking along the beach. Why wouldn't he be? Okay, so then if we were to click on the backdrop here, you can see that the stage now is in blue. So before, when I was on my sprite was highlighted in blue, and then when I click on my backdrop, that's in blue. So what this starts doing is I can now add code to my backdrop. And I'm not going to go into all of that today, but have a play around with that, see what you can do with the different backdrops. But you can then actually start building code in your backdrop. Back to the axes that I spoke about earlier, the really nice thing about Scratch is it's got a backdrop that looks at your X and Y grid. So if you were to click on that backdrop, what this helps certainly kind of break down, I guess, the geometry of Scratch is this helps with understanding the X and Y coordinates. So you can see how these are positioned on the screen, and it just helps the learners to kind of understand where you want to, kind of the placement of the sprite and what the coordinates are. You can see here are the minuses, these are the pluses, and then same for the Y coordinates. So this might be a nice exercise to introduce to your students, just to get them familiar with what we're talking about, the X and Y kind of axes. But for now, I want to go back to my beach because it's more fun. Okay, so now we've got our little cat moving along the beach, which is very nice. A couple of more things I wanted to show you, but also what we've kind of seen is he's walking a bit weird. He's just kind of gliding along the screen. He's not really walking like you'd expect a cat to walk. So actually, what options do we have to try and make him a little bit better? Okay, so we're not giving him a piece of code, but actually what we're looking at is him as an actual sprite itself. So what you can see is next to your code, you've got this option that says costumes. So if we click on costumes, then actually what this does is open up a whole different area where we can make our Scratch cat a little bit more exciting. And you can see here, costume 1 is the standard cat. And then costume 2, if we click on that, his feet are in a different position. So if we alternate and click between the two, then actually what you start to see is that between the two costumes, he's almost doing a walk-in motion. So actually, we kind of like that. We want him to start walking like properly. So now we know that the costume is in here. What we can do is go back to our code and then find where that costume is. Okay, so when we again think about how he looks, then again we're kind of looking at, we want the look of the cat to do something. So then what you can see is we've got a couple of pieces of code around costume, and we've got switch costume and we've got costume 1 or costume 2. So we could say, okay, switch to costume 1, then to costume 2. But actually what you might then need to do is do that in a forever loop, because it's just going to change it once. But then you've got a more simple piece of code that just says next costume. Okay. So then if we drop this in, and where's the logical place to put him? So really, you want him to change his costume when he moves, because he needs to move 10 steps, change costume, wait, and then obviously if he's on the edge, bounce. But then you want to loop that around, so he's always changing costume. So if I put that after wait, and then we hit the green flag, and then you can see our little cat's actually looking like he's walking. So he's not doing a strange glide, he's actually now walking along the beach, and you get to the edge and he bounces back. Okay, so he's looking a lot better. Okay, and then what I wanted to also show in costume is, you may have seen all these options here. So when we're kind of looking at the look of our cat, we can also play around with his actual look, so his costume and what he kind of looks like. So if I go to costume 1, there's different kind of options that we can do, and again you can explore and you can have a lot of fun with this, because this is where you can kind of paint different things and kind of play around with colour, and really anything goes, because if you went wrong, you've got this kind of backwards button that allows you to undo something you may have done that you're not happy with. Okay, so if I look at fill, I know that up here my fill colour is going to be purple. So at the moment he's a ginger cat. But if I kept my fill on purple and then hover over the cat, then what you can see is I can actually start playing around with the colour of my cat in the different areas. So I want him to look a little bit more interesting. I mean, I've never seen a cat that's going to look orange and ginger, but it is still fun. So if I clicked on the little white of his tail, you can see that now you've added a bit of colour to the cat. And actually, I kind of want his belly to be purple as well. So now if you look at him on the stage, you can see that he's changed colour. And then if you clicked onto the next costume, I mean, you've lost that colour because you've only applied that to the first costume. So when he walks along the beach, I mean, he's going to look very strange. So what you can do is then do the same and kind of make your second costume the same as your first. Okay, so if you click down on the fill, there's plenty of different colour palettes you can play around with. You can pick up this.
Hello?
Oh, you made me jump. Yeah. Oh, did you have a question? Nope. Okay, so you've got this colour palette here that you can play around with, and you can see the colours keep changing. So again, just have a play with it, have fun with it, kind of see what you can kind of create with your cat. The other thing you've got is you've got brush. So I said about painting. So actually, I want to select my paintbrush. And then up here is an icon with your brush, and you can see that the kind of the font size of that is 10. So if I were to try and draw something now, it's kept within my purple, which I don't want. But if you try to draw something, I mean, that's a really big, horrible line. I don't want that. And that's where you can undo, and you can go back and remove what you've done. So what I want to do is I just want to reduce the line a little bit. So you can see now I've got a thinner line because I've reduced the thickness here, but I don't want purple. So again, I can go back. I want a different color. So actually I want to draw a little, I want to make him smile. So I'm just going to choose like a black. And then if I go back to my paintbrush, and I'm not a very good artist, so I don't know how this is going to go. But then you can see I've drawn a little cat now with a smile on his face. So he looks a little bit happier than he did before. And same concept, if I clicked on costume 2, I haven't done that. So 1 minute he's got teeth, the next minute he hasn't. He's a weird cat. So again, I can do the same on my costume 2. I mean, that's not exactly the same, but then if I click, then you can see he's got the same color in and he's got the same smile. So just in a couple of simple things I've done within costumes, I've actually changed the look and the feel of the cat. And again, you're in the paint area, you can do all sorts of things with your particular cat. If you didn't like the colours anymore, you've got like an eraser. So you can actually erase some of the stuff you've done. You might not want him to have whiskers, so you can erase the whiskers out. Or you might want to draw some more whiskers in. You can, this is literally your stage. You can be as creative as you want with this. Okay. So the other thing I wanted to kind of show you is that we've got one sprite at the moment. And then same with the backdrop. So you can see here you've got another little sprite with a plus sign. So you can add another sprite into your stage. So it's the same options. You can choose a sprite from the library. You can create your own. So if we really think of games and computer games, then this is where you and your kids can really kind of have creative license to do whatever they want to do. Surprise, so again, it will choose one for you, or you can upload a sprite. So again, you might have an image or a photograph that you want to upload. But again, if we look in the library, then you can see similar to our backdrops, you've got lots and lots of different sprites. Okay, so you've got like lots that you can choose from. And then what it does is categorize it up here. So you can choose different areas up here. So I'm going to stick with animals actually. And you can see you've got your scratch cat doing a little walk. One thing I do like actually is if you hover, if you put your mouse over the sprite, you can see it highlights in the box, but you can see the different costumes. So if you're, so this butterfly, you can see it's changing. So it's got a number of costumes available to you, but some of them don't. So the beetle, you'll see he's not moving, so he's only got one costume. So this helps you understand that if you select that sprite, you've got a few options to play with, but also where you might want to create your own additional costumes. So actually, I haven't used the butterfly yet, so I'm going to use the butterfly. So if you add the butterfly in, you've now got two sprites on your beach. And what you can see is this butterfly is quite big. It's a lot bigger than the cat, which I think is a bit of a weird butterfly. So what you can do is you can now see here, I've clicked on my butterfly and my butterfly box has highlighted. So now I'm in control of my butterfly. So my scripting area is blank because I haven't applied any code. But also you can see here that it's highlighted. If I were to click on Ginger, the code comes back and everything you're now doing is related to Ginger, okay? So if I went to my butterfly, and again, just playing around with different tools, you can see here that the size of it is 100. So actually what I want to do is shrink my butterfly a little bit. So I'm going to set it to 80, and you can see it's got a little bit smaller. So again, he's a bit too big for me. So I'm going to shrink him. And now you've got probably a decent size little butterfly that you can play around with. Okay, so this is a very kind of high level introduction to show how you can have two sprites, 3, 4, you can keep adding sprites into your backdrop, and you can code to each sprite, and then you can actually start making them interact with each other. And I'll show you an example of what I've done in a previous project. But just so you know that, again, you can go into Sprite. I want to add something else in. If I go to animals again and add a little chicken, then I've got a whole host of animals going on now. So again, you've got 3 sprites in this area, and you can keep coding to each sprite. And then you'll see a little dustbin kind of icon with a cross through it. So I don't want my chick actually. I think my chicken's ruining the beach. So I can click on delete and it takes my sprite out. So again, it's just to build up how much you can do with scratch on just the basics. I mean, we're still really just in the basics of Scratch. And then what you'll notice is you'll start to see that the butterfly starts to, when you've got your code, then where we had your Scratch cat, you can now see that the word butterfly comes in because you've highlighted your butterfly here. Okay, so what I wanted to do, and I know I said to save this until towards the end, and luckily not everybody has their Scratch downloaded. But what the final piece I wanted to kind of show you before I show you a previous project and stop talking is that right now there's no sound on my animation. I've literally just I've just made my cat move and say a few things in a speech bubble. But what you can really then do is play around with sound. So if you click on sound, you have a whole host of options here. So before my cat says hello, I want my cat to meow. And you can see that that Scratch already identifies that you've got a cat. So it will give you a sound that relates to that particular sprite. So I want to play the sound meow until it's done. So I want to say that. I want to do that just before he says hello. And I might need feedback to make sure you can hear this. But then if I was to hit the green flag.
Yes, loud and clear.
Yeah. So now my cat.
And there was a question somebody asked, can we make the cat do meow? That's now answered.
There you go. So again, when you're playing around with sound, I think adults and kids, I know I got excited, they do get quite excited about the sound, and it kind of loses concentration because all you hear is animal sounds going on all the time. And then what you can see next to costumes, there's a sound tab. So if you click on the sound tab, then you've got a number of options that you can do, okay? So if up here, sorry, down here, you can see it's similar throughout. So the pattern of how to use Scratch is the same. So you can choose a sound from the library. So if we click on that, again, it opens up loads of different sounds. And again, it is kind of categorized for ease up the top. So if we went into animals and sticking with my cat, and I think this is where the kids go crazy. Oh, we're just using a meow, but we've got a meow too. So you can see the meows are slightly different meow. So if I were to select that, then what you can see now, I've got two sounds here. So I've included another sound. So if I went back to my code, and again, if you come into a bug, you can't see your code because my butterfly is still highlighted. So if I click back to Ginger, my code comes back. And where I've said play sound meow until done, if I click on the drop down now, oh no, it hasn't come in. Oh, you should see the second meow. Oh, I know what I did. So actually it's because I had the butterfly clicked. So if I went to my butterfly, I've got my second meow. So actually that's a good, I went wrong. It's a good thing to do. So if I clicked back on the cat, I need to add my meow back in. And this is where you can really start to think about what the problem is. I didn't realize I had my butterfly clicked and it didn't do what I wanted it to do. So now I know I've got Ginger clicked, I've got my two meows. So then if I go back to code and do my drop down, you can see here I've got two options. So I prefer the second meow because it just sounds, he sounds a happier cat. But then what's really fun and where I make a fool of myself is if we go back to sounds in your options, again, you can upload something. So if you've got musicians amongst you, you might record some music or something that you want to upload. But what you can do is record sound. So you can record, maybe you want your cat to say, hello, my name is Ginger. but I'm going to actually meow because I think it's better. So if you click record, and you've got a recording panel here, and you've got a big button in front of you that says record. So I hope this works on a headset, but I could then click record. Meow. Okay, let's listen to what it sounds like. It didn't do anything. So let me re-record. Meow. If you stop recording, meow. Oh, brilliant. And then you can save it. And then you can see you've got a recording now. So you've got 3 options of sound. And if you go back to code and play sound in your drop down, you've now got a 3rd option, which, let's face it, is the best option. I should be a cat in my next life. And then if we play it, meow. And then he does his little walk.
Oh.
Okay, so again, if we look at the amount of code I've used, it's really not that much code, but what we've had to do is tell Ginger every single thing we need him to do. He doesn't have logic, he doesn't have any kind of common sense. He will not do anything unless you tell him to do it. But actually, we've got him to do quite a lot just using a few pieces of code. This forever loop, and I think this is a really powerful piece of code, and there's a concept called lazy coders. So if you're coding constantly, you're always going to want to keep using a piece of code that you've used before, or you're going to kind of want to keep it on this forever loop, and that's where you've seen a pattern. You've recognized that pattern, and actually what you now want to do is you're pulling the key bits of that pattern and just repeating it to allow your cat to move. And then just before we kind of look at the break, what I wanted to show you is, and this is what we're encouraging with Africa Code Week, is when you've kind of created your project and the stage is yours, you can do whatever you want to do. You can play around with all these different areas. I mean, if you do something wrong, it's great because you can try and figure out why has it gone wrong. I did it with the meow. It's because, you know, I hadn't paid attention that my cat wasn't highlighted. So actually you can really start to think, why is Ginger not doing what I want it to do? And then you can, up here you've got file. And if you click on file, you can save this particular project to your computer. So if I did that now, and you can see I've got a few here. So mine had a chick, but now I'm going to save it with a butterfly. So I've saved my project, and then these projects can be uploaded. I think at the end we can kind of put additional resources and where you can kind of save your projects. But you've now saved this, so you can use this in future. And if I were to go into file and load from my computer, then you can see I've got a number of different projects that I've already saved. So if I click on one, I can upload it. And then you can see I've got a totally different backdrop. I've got little chickens on the go, similar with my cat, but now he's in the Jurassic area. And then each sprite, you can see there, I've got another piece of code to each sprite. So I've already saved a project that I can maybe pick up and edit afterwards, or I can use this time and time again. So this file feature here allows you to save and then obviously load projects that you've kind of already done. So this is kind of just the real basics in terms of how to get started, getting you and your students used to the fact that you've got a start command. So what event do you want the code to start from? You can't just build the code from scratch. I know that sounds cliche, but you always need a starting point. So if you didn't have a starting event, this code's not going to work. It's not going to do anything. It doesn't know when to start. So you need a start point, and then obviously with the green flag, you always need to stop it. So again, and you can see he's interacting with the little chick here. This little chick's in the way. I haven't done anything really with it, but I've now got 3 sprites moving around with just a small piece of code. So obviously, thanks for the feedback. Now that is a cat. Yes, it is a cat. It's a purple and ginger cat. But yeah, hopefully it just gives you the ideas that you can play around and make anything look as anything you want. And there are some tutorials in the Scratch desktop that you can also look at. But what we're going to do is kind of break for 10 or so minutes. And then Mesamil's got the amazing task of going through a bit more advanced coding for you. And I think he's going to use the calculator algorithm that he went through on the theory to kind of help show how you can actually put some real intelligence behind Scratch, but again in a really simple way for the end user to kind of start building a bit more complex code. So if we are all good, if anybody's got any questions, continue to write them in the chat during the break. But I'm going to stop sharing for now, and then what's the time? Ms. Emil, what time do you think we should?
I think we should do a 5 minutes break, not 10 minutes. It's a 5 minutes break because
5 minutes?
they are still on the call. But within the time, if like Sarah indicated, if any teacher has any comments, any questions, wants more clarification, this is a good time to voice it out, or you can put it in the chat box and it will be attended to. So yeah, I think 5 minutes break.
Okay, so if we come back at 10:50.
That's.
Can we make it?
Can we make it what? Go ahead.
10 minutes instead of
10
5
minutes.
minutes break. Yes, please.
Why 10 minutes?
I think Francis, it's fine for 10 minutes because yeah.
Okay, well, if we say come back at 12:50, and then if a couple of people, and we can wait a couple of minutes if need be.
And Sarah is saying 12:50 because the UK is an hour ahead of us, so you are ahead of us by an hour, so it will be 11:50.
Oh, of course. Sorry.
Ghana time.
I don't know what the time is in Ghana.
You are just an hour ahead of us.
Okay, Francis, just tell people what time they need to be back.
11:43.
We can't hear you. Ernestina. Sorry. Ernestina, were you saying something? Anyway, so we will resume the training at 11.
Yes, please. I was saying that the break time should it be 11 o'clock? Okay, that's 6 minutes from now. All right. Thank you.
So yes, 5 minutes, 11:50, and we are back.
Okay.
I mean, you don't need to go off. You can still stay on. But if you have any comments, if you have any questions, this is also a good time to note it down and let's have them so we can address it.
Yeah, we are staying here, so if you have any questions, we can answer by that time. One of us will be here.
Ms. Mill, I'm going to quickly disappear for a
I
minute.
will be here. Sorry, I
and then
will be here.
Yeah. And then maybe I will make the butterfly move later.
Yeah, that's the question. That's what they have to.
Yeah, I might do that after I come back, actually.
Yeah. So by then you can ask any question, whether it's related to the Scratch tool or it's a generic question, or how do we anything. It can be any question.
I hope that cock crowing wasn't the sprite. Oh, this is a real cock.
It is actually quite fun, isn't it, doing this?
It could also be somebody playing around with a sprite.
No, I think it was the real.
That's a real one.
Real, yeah.
It's
And
really
Isaac,
funny.
I have sent you the link. You can download the latest version. Yes, Sarah.
Well, I forget my camera's here, so I'm looking in the camera, but I can see myself up here. So I keep looking up here.
No, in Sarah, in your absence, there was a sound of a hen. So we were wondering whether it was a sprite or it was a real bird.
Somebody should record it and upload it.
Someone was asking the butterfly can also fly around.
Yeah, so I'm going to duplicate this code because I'm being lazy and I don't want Mazamil to miss out on his. Oops. What am I doing? Oh, I didn't duplicate it. Hold on.
No, master.
I thought I just drop it in here. Well, this serves me right for being lazy.
Can we start doing something on a laptop?
Yeah.
Oh, it is there. So I wonder if now we've got a pop. Okay, where's my? I want my butterfly to start over here. You can start to hear little sounds, can't you? And it's 106. Oh, actually, that's a good thing to call out. It's a very excited looking butterfly. Meow! Huh.
Maybe you can delete the ginger sprite, then it will look only butterfly.
Oh, I don't want to delete Ginger. I've just spent an hour creating him. I might just take out the meow. Oops, didn't mean to do that. Meow! Why is it still duplicating? Okay, that's duplicating automatically. That's weird. want him to come down a bit. He was in the way of the butterfly. And then he's minus 61. Ah, look at them walking together.
Yeah.
I'm learning something here. If I can
Please, I can't hear you. I've been trying to hear a voice. I've been online, but
Hello. Please, can we hear? Hello? Hello?
Hi, we can hear you.
Okay, great. Okay, so please, for some of you, we are not getting your names, okay? We are seeing your nicknames, and we need the names for your certificate. So kindly send your actual names to us. For some of you, we private messaged you, but you haven't responded. Please respond with your actual names because we need it for your certificate. Okay.
I just typed our names in the chat.
So my name is Sarah. Oh no. Hold on. Yeah.
Oh.
I met a few Sarahs in Kenya. I don't know if Mizamil is a good
I'm just
African
checking
name.
with them if they have a Muzamil there. Because I guess Sarah, even in India, it's a common. Yes, I mean, especially in every part of the world, you'll have.
Hello, Sarah.
Hello.
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 Francis, are we going to start? Because we have only left is 35 minutes.
Yeah, I think we can start now. Yeah, we can start. Oh.
Okay,
Yeah.
I'm going to stop sharing, Mizamil.
Yeah, I will share my screen.
Cool.
Perfect. And
Hello.
Hello.
Hi. What is that?
Is my screen visible?
Yes.
Perfect. So I will continue what Sarah has already told, but I will be taking the same example which we took at the end of computational thinking. So maybe can you type in the chat what was the example we looked where we tried to break it into 4 steps? I showed you one image. Okay, so okay, let me only tell you that we try to use the calculator. So let me take it further and decide, and we together can try to build a calculator. So we discussed that we break it into addition, subtraction, division, and multiplication. Yeah, Sarah is right. So what we do is, let's take one by one. Let's decompose the problem, and we will develop it one by one. So what do you think we will need to calculate addition of 2 numbers, right? If I think I will need number 1 and I need number 2, and then I add those 2 numbers. But if a kid has to do it, how will we do it? The first step is the same. Let me also do like how Sarah tried to show you. I will first try to have some background. First let's get rid of the cat now, because it's a math class now. Let's pick something. It's up to you guys where you want let's pick, since it's a math question, I will pick say school. And in the sprite, I need to pick somebody who will teach the kids. We can pick like this guy. Okay, so now this is our sprite. So like how Sarah showed you for the cat, it's up to you, and it's up to the kids, whatever they like, they can accordingly pick the person. Now, next thing is we need to now start writing the code so that 2 numbers are added. Let's go with addition first, and I will show you how simple it is to do multiplication or division or subtraction. So like I told you, we need like a start. So I need to say what happens when the sprite is clicked, right? So this is like how Sarah also explained, this is the starting point. First thing I need to now do is to add 2 numbers, I need to have a variable where I store the number 1. Normally in maths, you will always use X, and then you create another variable and you store it as Y, and then we will add X plus Y. That's how you normally do it in the school, right? So let's also do the same thing. I will be going through the other one. So to create the variables, these guys have provided very simple. You don't need to write any code. You just click on the variables. And here it has my variable, but we can also have our own variables. So let's create our own variable. I will say my first variable is X, where I will enter the first number. I have an option either whether I use it only for all sprites or I use it only for my sprites. So I will say let's it for all. So now if you see an X comes here, yeah. So, and I need another variable to say that it has to store Y. So let me go here. I say, okay, it is Y. Okay. So I say, okay. So now I have 2 variables created. Now at the beginning, whenever you open a calculator, you will always see a value 0. There will not be any value. So I use this set my variable, I write here my variable name, it's X, right? I set it to 0. And I say set my variable Y also to 0. Means in the beginning, when this guy teaches, this should be 0. I don't need to complete the code to see how it is. I will just say execute, and you see these are 0. If I would put something else in the beginning, I wanted 10 and I wanted 12, or I may like make it something else. And when I click, you will see the code gets executed and your X and Y comes here. But it's always a better option to keep it 0 and keep it 0. Now once we have declared our variables, we need to write some other code, like I can say that let's make this guy move a bit before he actually speaks. Yeah, so I just put like how Sarah explained. I was just showing you different. And what they have done, MIT guys have done, is they have divided all the commands into different. So all the motion related ones will be under motion, all your maths related will be under variables, and all the operations we do will be under operations. If you need any input and output, they are under the sensing. So they have done it very easily so that kids remember. Now, if I click, say click, see, you see the kid, the person is moving and the values are becoming 0 and 1. Now, I need to ask, since it's going to be kind of a program, this guy needs to ask you that let's add 2 numbers. So how does that happen is we have to drag the say. Yeah, I say here. Or even before say, you can even think of putting think. So if you put think, then you will see it showing like this, or what should I think? So here, I will write, let's do something. Okay. And if I now try to execute this code, you see, he's thinking, like, yeah, that's how you teach it to the kids. I say then, okay, I drag it. I say, let's add 2 numbers. Yeah. So if I stop it and if I see, it says let's do something, and then it says let's add 2 numbers. Now in this program, we need the user to input these 2 numbers, x and y, and then our sprite will calculate the result. What is the x plus y? So to do that, what we need to do is we need to ask now the user to give the input. So that happens always in sense. So basically, you can understand, I have to ask user to give the input. So I go to sense, and I put this ask, because now I have to ask the user. Instead of asking the user what's your name, I will say enter the first number. Okay, I say enter the first number. Okay, so what you can do is whenever you are doing it, you can immediately test it then and there. So if I stop it, I say execute. This guy moves a little bit, then it says let's add 2 numbers, and then since it's an ask, it will ask me to enter the number. So I enter the number 123, but this number 123 has to be assigned to x. Like we said, that computer, unless you don't tell it, it doesn't know. So you have to tell, next step should be that this number should be assigned to x. So whatever you type here always gets stored in a variable called as answer. So next step should be, if I do after this, nothing happens because I haven't told the program what to do now. So what I need to do now is I need to set this to variable x. So I say, I go again to set, and where was this set? You know the color, it is here. So I say to the answer. So whatever answer comes here, it will be assigned to this variable x. So let's try it out. I say execute, let's do something. Again, the same code gets executed and it tells me enter the number. I enter the first number. Okay, I say okay. Now you see here, the number got assigned to x. If I don't write this code, it will never work because the system will never come to know that what's the value of x. Now, what should be the next steps? I have to do the same code for y, but I don't need to write it again. What I can do is I will move this code. I will say Control C, which we have used, Control C and Control V. I say Control C, which is copy, and I say paste, Control V, so that I don't need to write it again and I don't need to drag it again. I can always use the existing copy paste. So, you don't need to write every command every now and then. You can write it anywhere. But after x, what should be my next variable, which I have to assign the other number to y. So I will change it saying that enter the second number. I say enter the second number, and I assign the second number to y. Okay. Now let's test. It's always better, whatever you do, you just test it. Otherwise, it may have some error. You will come to know there. So here I enter the first number. It gets assigned to 322, and then I have to add the second number, 22, and you can see now both x and y. The computer knows now what are the x and y. So after I have given x and y, what should be the next step? The next step is I need to tell the computer that you have to add these 2 numbers. And how do we do addition? Addition will, what do you think among these options? Where should be the addition? Addition is an operator, right? So it will be present inside operator variable. So now just by thinking, the kid can realize where should my icon like if I want to make the noise, some sound, now I can go to sound. If I want something to move, I will go to motion. If I have something to be taken as input, I go to sensing. If I have to create some more variables, I go to variables. But now my job is to make computer say that you have to now add my X and add my Y. So where do I find it is in the operators. You can see here. So I drag my operator here. Now what I need to do is I need to do X plus Y. So where are X and Y? They are residing under variables. So I drag my X here and I drag my Y here. So now my X and Y are added together. But now I have to show it in the system for the user, saying that, oh, I have added your number. So how do I tell it to the user? I again go to say. I go here, there's a say, right? But here, if you see, it's only giving me one box, right? But I want to say the answer is, then I want to say X plus Y. So there is one more function which you see in the operator, which is called as join. So I can join two things together. In the first one, I say, well, the answer is, and instead of saying the answer is banana, I will say the answer is whatever is X plus Y. Okay. And now let's see whether what we wrote is working fine or not. I just say, okay, start. He moved a little bit here. And instead of saying it, you move it to a particular thing, you can even tell it here, I delete it. It's very easy. You just click and delete. I say go to random position. Instead of moving 10 steps, you just go anywhere. So now let's start. I say click, it goes there, right? It's up to you, whatever code you write. Now it says, let's add two numbers. I enter the first number, 23. Now you can see it gets assigned to X. Now it says enter the second number. I assign the number this, okay? And when I say enter, you see, well, the answer is 3468. But did you realize something? By the time I could read it, the message went. So I can use some other operator which says, okay, I need to make it wait for some time so that, user can see the answer. So I say wait for 2 seconds or 3 seconds there, okay? I again click, you can see it just went to a random position. It's telling me let's add two numbers. I enter the first number, I enter the second number, and you see the answer stays there for some time. But if you can see in the computer or in the calculator, like how you see X and Y, you see also the result, right? Which shows me the final result. So let's change a little bit where we also create one more variable which can store our result, because currently we are not storing it, we are just showing it. So for that, see how simple it is. That is how the kids will now improve this program. I will drag it down. I will create one more variable with the name, say result, where I will store the final result. I say, okay. And I drag it here and I say my result should be set to 0 in the beginning. Because if you see now, everything is having some numbers, but by the time I click, because of this code, it brings it to 0. Remaining code stays the same, but just before putting up the result, what I can do is I can set the result to something. I say set my result. What should it be set to? It should be set to X plus Y, right? So I can take this out and say put my result to X plus Y. So it means whatever is X plus Y, put it inside the result, and here I can directly say, well, the answer is result. Okay. And now let's see. Now if you see, because I created this result here, it's showing me one more variable here which says result. So let's try it again. I say, okay, let me click. Oh, he went out because I have told him to go to random positions. It says, okay, let me set the first question. Yeah. I say number 123. Now I say, okay, enter the second number. I say, let me say 2334. Yeah. Now, if I say, okay, now you can see your result has come here. It's shown here, 157. So it's almost like a calculator, but you're only doing the addition part. Now it should be easy for you. Now, if you guys want, say no, the students want to learn a subtraction. So what, so say division or say multiplication. Let's take the example of multiplication. You don't need to do much. You just need to change the text here. Let's multiply two numbers. Yeah. Okay. And I made a spelling mistake. Okay. So here, what we need to do is, instead of using this, I need to delete it now. I need to create another operator, which is for multiplication. I see it here. And to this, what should I add? I should add my x, and it should be multiplied with y. And I add it to the result, and this result I show it here. Now let's run this program again. I say click. Oh, he's going up. Maybe I should get rid of this random position. It says enter the first number. I enter 12. And enter the second number, say 34. So this time it multiplies these. 12 into 34 is 408. So this is what we call as here you can easily understand the problem of pattern recognition and an algorithm. We identify the pattern that we need two variables and a result, and then using the algorithm. Now I think if I don't know if I have it here. Oh, it's here. So if I go back to my example where we wrote this algorithm, right? We start, we declare two variables, and here I declare two variables. Then we ask the user to put the first input. Here we ask the user to enter the first number. Here we say the user that, you enter the second number. Here I have entered the second number, and then I do the operation, which is x plus y. It can be anything. It can, as and when kids will learn, they can create different formulas. They can do a lot of mathematical things. They can use it for fun to create different things and make this guy do different things. When the result is out, you can even add a sound to it. Like how Sarah said that we can create different costumes. Like if you see this guy is having this costume, and just to make them fun and not only teach them math, you can go to another costume and change something. Maybe change his dress. I will change, I change his clothes to some other color, and I change his trouser to some other color. That's how kids will be this thing. So this is now my second costume. Then I go back to my code, and in the beginning, I get rid of, say, this code. I put the costume. I have to see where is the costume one. There is one place. So here's the costume, right? In the beginning, I say switch to costume A. Okay. And by the time he's about to tell you the result, I will tell him that switch to costume B. Yeah. That will make kids like learn the coding, as well as at the same time they will enjoy it. Now, if I run this, if you see, he is now wearing the old costume, and he says, let's multiply two numbers. I enter the first, I enter the second, and you see when the result comes, his costume changes. Even the same thing you can do as next backdrop. You can change the backdrop. And one more thing is, now you can slowly increase the, we can slowly increase the complexity of it. Like if you see, it's only asking me to multiply once. What if you have to multiply 2 times? So like how Sarah said, that we go back to the control, and I say repeat. And repeat how many times? I want it 2 times. Okay, and then I drag my code and I put it here. So it automatically comes under repeat 2 times. So now I don't need to wait for 3 seconds. I can get rid of this. And how do you get rid of? You just select it and press delete. So you don't need any coding background. It's just plug and play. Now let me run it. It should be asking me to enter value twice. So I say run. It says, let's do something. Let's multiply two numbers. And it asks me the first number. And it asks me the second number. It says, well, the answer is 36. But I am not pressing anything else. See, it's repeat second time. So again, it's asking me to enter second time. You can keep it enter like 10 times. It's up to you. You can use, I will just briefly tell you what are the controls which you can use. You can use for wait. You can upfront tell it repeat. If you want something to be like keep doing, you just put it in forever. But we have seen at times you want to do, if there is situation A, you want to do something, or if it is situation B, then you want to do something else. So you can use if else. I don't know if guys who have done coding, they can understand this. I say, okay, if cat is black, then run this code. Otherwise, you use the other code. And here also you can wait until say 10 seconds. And same way we can go to sensing. Here you can do a lot of different things. What should happen when a space is pressed? So what should you want the system to do? Maybe you can even say, okay, and then I want to change the backdrop. And same way we have a lot of variables here. You can create variables, you can hide variables. So this will be used for your computer if you want to create a calculator. So now after knowing this, we don't have time enough. Otherwise, what we could have done is we can create this calculator in the sprite. And then for each line, we can write a code. Like if I say 8 gets pressed here. Once I say into multiply 9 and I say equal to, it will run this code. Okay, this is a multiplication. It will run this code. Like how we say, you don't need to even write the whole code again. You can just duplicate your code and it gets duplicated here. And now I can say subtract this code. And if you don't want it, you can.
Sorry to interrupt. I think we have got a bit more time. Francis, what is our finishing time?
No, we have to finish it in Indian time. It's still 6, so we have 12 minutes.
Okay.
I
thought it was hard. Okay.
Okay. So that is one thing, but our main goal of this exercise is that you just it's not to teach you or tell you what to do and what to create. It's just that to let you know that this is how it works. And one more thing, yeah, maybe I can show you. Once you write a lot of code, it might happen that you want to run it again. So what you do is you can click on files. You can click save on computer and you can give any path. Okay, I say on the desktop, I say African code week. Okay, ACW. So what I do is I just close this and I say leave. But when I go inside this scratch and it will show me again a blank screen. It can happen that you have done only half of the code and you want to go somewhere and then you don't want to write it again. You can just come back, you say file, you say, okay, load from my computer. I have stored it on my desktop and I go back here and I say share. And what happens is my whole code comes and I execute. So it's not something every time the person has to come and write a new code. But yeah, this is how you can do it. And like Sarah also put it correctly, that there are a lot of functions, and especially for the kids, they can come up with a lot of games. Maybe once Sarah will also, we will just show you some slides where you will find more information, as well as you will find some videos where already teachers who have used this computational techniques. I can tell you, because in India, we have used these things for the kids. And like I said in the beginning, you are really amazed at seeing the creativity of the kids. They are much more creative than us. And in just 2 days, they will come up with their own game, with their own rules. I mean, you can ask kids to create games and they can create like playing football or bouncing off a ball. They create their own games. And best thing about this is there are no rules. It's up to them. It's not something which is like where we have to force them to do. They will of their own do it. And it's much better that they use these things rather than using the social media or watching cartoons, because this will for sure, at least I know it in India, it has improved the the knowledge, their precision and their decision making much better. I think we have 10 minutes. I will, maybe Sarah, you can show the remaining slides, and then if there are any questions, we can take it.
I was just going to say, can you just show that you've got, your code is quite long on the screen. So I just wondered if you could.
Okay, it's long. Okay, let me, how do I zoom inside? Is there a zoom option? Oh, maybe here. Is it now visible?
It is, but I just wanted you to show the two little icons that make you zoom in and make it smaller.
Is there a zoom icon?
In the little script area. In your script area
down. Oh, sorry.
Yeah.
Yeah. Perfect. So yeah, he can, because obviously when you're going to code, it will be lot of code, and you can even add the comments also. It's like how we normally do it. You can add the comments why I added it here, so that tomorrow if somebody sees my code, he can tell, I will say I used it twice because my teacher told me, or something, so that somebody seeing your code, he can understand why I did it, and you can delete it. So yes, that is from our side. We maybe can show you the slides, and we can take any open questions if you guys have any.
Okay. Okay, just let me share this last slides. I like that the pupils do what the teachers tell them to do. Okay, did you want to run through this, Mazamel?
Yeah, maybe. So
Hello,
this is.
I have an addition.
Yes.
With your code, could you please put back your screen?
Okay, my code, yeah, I can.
Yeah.
Then I will have to share my screen again. 1 second. Where is my Zoom? Here's my Zoom, and here I say share screen, and here I open my Scratch. Yeah, that's the advantage of saving it. You can anytime go back and load your code. Yes.
Okay, so there's just a little other question, right? Realize that when you were done, when the lady was saying, well, the answer is the result, it only lasted for a short period of time and then it disappeared. Yes. So if you want it to keep longer for us, realize that you have for 2 seconds.
So how I can do that is I just have to go back to this controls. Here it says wait. See, now what happens is it says the answer and in 2 seconds it goes off, but I want it more. Suppose if there was no 2 seconds, I can drag this wait here and I tell it, I don't know why it's acting crazy, it's duplicating. It's the same problem with Sarah was happening. I don't know why it's duplicating. 1 second, undo.
Hello.
That's, yes.
Hello, please, apart from this video, can we also have another video tutorial so that we can practice more?
For this, you mean another session?
Yes, please.
That we will take it back to, now it's working. We will take this back to Francis and maybe let me do
if you put the weight in and then it duplicates, remove the one behind.
I don't know. Okay, because it's selected completely. Let me unselect it. Oh, what's happening? Delete these 2 blocks. Or maybe I can just create a fresh one where we just put the weights. I will show you quickly the weight with maybe with the cat only. I just say that when clicked, I say hello, but since the hello will go after 2 seconds, I want it for longer time. I say wait for 10 seconds. So now, I don't know why my laptop is acting weird. It's not typing it also. Come on. Hello, am I audible? Now it's working. So if I say, now you see hello will stay there for that much time. So, and here also you have two options. One is you can use hello with existing time, or you can use just a hello and then add wait time to it. So that's what I'm saying. You can play around as you want, and a lot of creativity will come with the kids when they do it. And regarding the second question, we will take this feedback back to Abraham and Francis and ask them that we got a feedback that there should be more sessions so that you can we also get more time to teach the same thing. And maybe Sarah will share the screen, because what we have compiled is in this presentation is different links, different videos where it is described in more detail. Like you can see, yes. So here you can see there are already lessons for teachers where you can learn more about this computational thinking, where you will learn more about this. So maybe Francis, you can provide them the slide deck. So same way you can see your skills, and then maybe there's one more, right? Okay. So these are the details where you can, we also know that there are places where you don't have computers and you cannot give it to everybody. But if you go to these links, you will see that how kids can learn coding just without a computer. So we know, at least it's the same in India. Every kid doesn't have an access to Scratch, but these links you can use. And also in this link, you will have all the different materials which you can use for your coding sessions. And also one more thing is, like I think somebody asked me before, is that MIT has already created these projects, like how to create a game, how to create a calculator. So anybody can look into that and make the students also do the same. So it's not something you have to go from scratch. You can, from the MIT, they have a library where everything is mentioned. Maybe Sarah, you want to add?
No, I was just going to add, can you hear me? Yeah. Just to
Yes,
add that so Francis and the team will be able to kind of share this presentation with the links to further material. Obviously, we've shared the Scratch link in the chat, and then this session's already been recorded, so you can listen back. And the best way to learn is actually just giving it a go. Use code, go wrong, try again, and then we'll feedback. Yeah, we kind of feedback the questions and about the follow-up sessions. Did anybody have any other questions before we conclude? Okay, Francis, did you have any other questions? Did you have anything else to say? Hi there.
Hello. Please, mine is not a question. Mine is a suggestion.
Yes, please.
Mine is a suggestion. Yeah. It seems today's lesson you were moving a little faster. If the subsequent ones to come a little, will be very glad.
Yes, ideally what happens is that these sessions normally will be a classroom sessions, and we have enough time to explain, but because of COVID, we have a fixed time where unfortunately we have to finish the course. Yeah, but yeah, ideally if it was normal scenario, not a COVID scenario, we might be doing it in a classroom where you have the ample time to do it, not in just we have to squeeze everything within 3 hours to tell what is computational thinking, what's Scratch, and how to create additions. But yes, maybe Sarah, you want to add?
Yeah, no, I was going to agree. We can feed that back, which is why the recording will be shared. And there's some tutorials and some existing projects that you can access through Scratch to also help further your education. So this was this was an introduction to Scratch and to kind of get you thinking about why you're doing stuff. But yeah, because of COVID, like Muzamil said, ideally we would be doing this face to face with you.
Jerry, yeah, that I think Francisco can answer about the certificates of participation.
Is Francis still on?
I think Francis is not replying. I don't know. And one more advantage you have of the recordings is that, like right now, you didn't have Scratch in your laptops or in your systems, and it was tough to follow. But once you have the recording, you can first download the Scratch, and based on the recording, you also can follow it so that you get a hands on it. And once you get a little bit of hands on, you will become experts in no time. Good. So there is no other question in the chat also.
Okay.
Is there any feedback you want us to take to the team or anything else before we wind up? I guess not.
We are just thank you so much for the tuition you've given us. We really appreciate that, and may God bless you.
Yeah.
Thank you for being great participants. I've really enjoyed it.
Hello. Hello.
God bless you all.
Thank
Hello.
you. Yes.
Hello.
Okay, bye-bye.
Bye-bye.
Thank you. Bye-bye.
Yeah, we really
Bye-bye.
appreciate it.
Yeah, thank you.
Oh,
It was
enjoy.
nice.
Have fun with it and get coding.
Yeah.
You too. Have a nice
And don't
day.
forget to create the monster.
Yeah.
Thank you so,
There's a
so
group
much.
there.
Hello?
Bye-bye.
Bye.
Bye.
Thank you so, so much, Sarah and Isabel. This is
Have a nice day.
Oh, you're very welcome.
Thank you so much for joining us today. We want to say a very big thank you for making this happen, and then to all the teachers who joined us even though you are busy.
Karen, you're on mute. You're on mute.
So,
I see a consent.
Hold on. Sorry, a minute. I'm checking another meeting. Just a second. Hold on, just a second.
There's another training session.
So,
How do we take a group picture?
But does that sound right, Sally? Yeah, I think so.
Tell me the number of you. Menjeli number king.
We don't know what else we can say beyond repeating what we said first time.
No number kima.
Yeah, I think
054.
okay, so we are ending our session. Thank you so much. Keep on practicing. We share the documents with you, the tutorials, we'll share the video with you, and then also send the credits for the internet. We'll be sending that as well. And then your certificate. Those of you who have it, when we share the link with you, get the credits.
Hello?
If you have any questions, any comments,
Today's station.
hello. If you have any comments,
I sent them audio. The remaining balance. And I send them. 115.
if you have any comments,
Yes, thank you so much. We really
Thanks,
enjoyed the
guys.
lesson today. Africa Code Week 2020 is always fun. Thank you so much. Bye.
Bye, guys.
Good afternoon. Please, my
Can we also
question
use
is,
multimedia encoding this same or
is there an app that we can use our phone in helping our case? Because me, for instance, in our school, we only have one laptop and using it is very difficult for us. Thank you.
Yes, so all that will be shared with you. Okay, we share the link with all of you. Go through the document. There are links to all that. How you can access the app online. Okay, there's one by SAP, which you can do online. It's available for those with Android phones. But for the iPhones, you have to wait. Okay. That's okay.
No t-shirt.
Okay, thank you.
You have any more questions?
I saw Chidi the case. Yeah. Can you be
Hello. I'm moving into another session. Thank you.
Hello. Hello.